Hi, welcome to Vision classes. It's classes for IGCSE, GCSE, AS and A-level student around the globe. So today we have to discuss one of the question from the paper 3 May June 2024. So it's a vector question and we will discuss the question along with the basic topics, how to solve it, fine, and related concepts as well. So if you haven't subscribed yet, subscribe to our channel. Let's start the question discussion. So here you have ABC have a position vector OA negative 2i plus j plus 4k and OB 5i plus 2j, OC 8i plus 5j minus 3k. O is the origin and the line L1 passes through the B and C. So we have to find out the vector equation L1. So let's see here. This is line L1. It passes through the B and C. Fine. So this is position vector OB, okay, and even this is OC as well. So firstly, to calculate this equation of a line, we have to write the L1. Equation of L1 is equal to OB plus lambda BC. Even we can take this one OC lambda BC as well. That's a one and same. Fine. All right. Now this is basic concept. Now we will firstly find out the BC part. BC is equal to OC minus OB. This is position vector concept. So OC is, we have a 8i plus 5j minus 3k minus 5i plus 2j is OB, right? And 8 minus 5 is 3i plus 5 minus 2 is 3j and minus 3k, okay, BC. And you can substitute here L1 is equal to OB is 5i plus 2j plus lambda times 3i plus 3j minus 3k. Fine. And here the coefficients are same, right? So coefficients are same. Even you can skip the coefficient as well, and if you want to keep as it is, that's also fine. And this is 3-mark question. If you know the concept very well, you can solve it quickly. Okay, so if you write it this way step by step, you will get 3 out of 3. So this kind of tips and tricks we explain usually in the classes. Suppose if you want to connect with us for a tuition classes, I have left the contact in the description box. You can connect with us right away. Fine. Then here we have a L1 has an equation given that negative 2i plus j plus 4k plus mu times 3i plus j minus k. So they said that here find the coordinate of point of intersection of L1 and L2. So this L1 and L2 intersect. We have to find out the coordinate of point of intersection. All right. So here let's say this is already I said here AB. The BC is the L1, right? And it intersect L2. This is L1 and L2, isn't it? This is L2. So we have to find out the parametric equation of L1 and L2. Fine. So the parametric equations of L1, let's say I will write here L1 parametric equation from this one 5 plus 3 lambda. Fine. Then this is x component, y component is 2 plus 3 lambda. All right, and negative 3 lambda. It's a parametric equation. So L1 and L2 parametric equation, it's a 2i from this equation here, negative 2 plus 3 mu. Fine. Then 1 plus mu and 4 plus 4 minus 2 mu. Okay, now you can compare the x component over both the side, x component and here x component, and y component just to find out the either lambda and mu. That's enough to find out the point of coordinations. Okay, so we will take the x component, that is 5 plus 3 lambda is equal to negative 2 plus 3 lambda, isn't it? 3 mu, sorry. So if you rearrange whole this thing, it will be 3 lambda minus 3 mu is equal to negative 7. This is first equation we will get. And second equation, to make the second equation, we can take the y component, here x component y component, so it will be 2 plus 3 lambda is equal to 1 plus mu. So 3 lambda minus mu is equal to 1 minus 2 is minus 1. This is second equation. Okay, so even you can put out in your calculator and calculate just values of lambda. Fine. So here I will show you how we can calculate these values. Yeah, you can see the calculator here, and here we have to take an x plus bn x is equal to cn. These are the two simultaneous equation. So a1 is 3 from this part. Okay, so a1 is 3 minus 7, right? Then a2 is 3, b2 is negative 1, c2 is negative 1 here again, and we will get the lambda is equal to 2 by 3 and mu is equal to 3. Okay, so we will use just any one of them to find out the point of coordination. So here we can substitute the lambda in the given equation to find out the point of coordination. So x, y, z, to find out the point of intersection, we can substitute here. Yeah, so if you substitute this 2 by 3 here, okay, so 5 plus 3 times 2 by 3 is just 2. So we will get x component as a 7, y component 2 plus 3 times 2 by 3 is 4, and negative 3 times 2 by 3 is negative 2. So we will get the point of intersection as a 7, 4 and negative 2. That's it. I hope you are getting it. Then next part is the point D on the L2 such that AB is equal to BD. Fine. We have L2. I will write the even equation of L2 as a negative 2i plus j plus 4k plus mu times in a bracket 3i plus j minus 2k. Fine. This is L2. On the L2 we have a B and D. Okay, so D point, and then this is AB. AB is another line, so we will take here A and B. Fine. So A also, we have a position vector of A at the beginning. So A is negative 2i plus j plus 4k, and B, OB is 5i plus 2j. We use this given things or position vectors negative 2i plus j plus 4k, and OB is 5i plus 2j. Fine, done. So even one more thing you have to do is that you have to write the parametric equation for point D on L2. So parametric equation negative 2 plus 3 mu, then 1 plus mu, then 4 minus 2 mu. This is point D actually. Point D we can represent in the form of parametric equation, that is negative 2 plus 3 mu, 1 plus mu, and 4 minus 2 mu. Fine. Then you have to calculate firstly AB, OB minus OA. So negative here 5 minus plus 2i, that is 7i. Fine. Then 2 minus j, just a 1 is just a j, and 0 minus 4 is minus 4k. So take a even modulus of AB, because distance we can calculate using magnitude. So it will be 7 square plus 1 square plus negative 4 bracket square. So it will be square root of 66. Fine. You can use the calculator as well. Now you have to calculate BD. Now BD distance you have already in the form of mu, isn't it? So the parametric or position vector of OD minus OB. Fine. Now OD, I will write it complete to remove the confusion. So it's a negative 2 plus 3 mu, 1 plus mu, and 4 minus 2 mu, minus here OB is 5i, 2j, and 0k. So we will get here negative 7 plus 3 mu, then 1 minus 2, that will be negative 1 plus mu, and 0, third one, it will be 4 minus 2 mu. Okay, and you have to take the modulus of BD as well. So it will be square root of x square, that is negative 7 plus 3 mu bracket square plus negative 1 plus mu bracket square plus 4 minus 2 mu bracket square. Fine. So you have to solve this completely. So and you have to simplify it as well. So it will be 49 minus 42 mu plus 9 mu square, isn't it? Plus 1 minus 2 mu plus mu square plus here 16 minus 4 times 2 is 8, 8 times 2 is 16 mu plus 4 mu square, isn't it? Then you have to simplify again here, and simplification we will get straight away 66 minus 60 mu plus 14 mu square. Fine. This is mod of BD. Now the distance of AB and BD are equal, right? So here mod of AB is equal to modulus of BD. Fine. So you have to compare. So square root of 66 is equal to square root of 66 minus 60 mu plus 14 mu square. Fine. Now take a square on both sides, so that remove the square root. So it will be 66 is equal to 66 minus 60 mu plus 14 mu square. 66 get cancelled out. Okay, so even take a mu common, right, and transfer 60 mu on the left hand side and 14 mu square. Okay, and simplify straight away mu, you will get 30 over 7. All right, so this is how you have to find out mu part. Okay, now we have a parametric form, the mu values are there, right, isn't it? So again here in this part, this position vector part, you have to substitute the value of mu to find out the position vector of D. Fine, this is not done yet. So here if you substitute x component, that is negative 2 plus 3 mu, y is actually 1 plus mu, and z is 4 minus 2 mu. Fine. Now you have to substitute this mu 30 by 7 here, right? We will get straight away 76 by 7 x component, and y component 37 by 7, and z component negative 32 by 7. So the position vector of D is equal to 76 by 7 I plus 37 by 7 J negative 32 by 7 K, and this is position vector of OD. I hope you understood this part in step by step. If you like this video, share and subscribe to our channel as well. Thank you. Enjoy the math.